Hi guys, another math lesson. We're working on lesson 33, session 4, and that begins on page 733. I did want to point out that now that we are working with these triangles, it gets a little bit complicated with the different types of triangles. So if you have your new packet that's available this week, somewhere in that packet, like in all the math pages, right before the lesson 33 pages in the packet, there's this poster. So if you guys already have that packet, I would recommend finding it, getting this page. You can tear it out or leave it in and just like have it open to this page. But this is all the different types of triangles sorted by the types of sides they have, and on this side is the types of angles they have. So I'm gonna have this poster right next to me that I can reference because the different types are kind of tricky to remember. So in case that helps you, put that on the side, okay? But for the first problem, we don't need that vocab. So for this problem, it says a website sells 7 different kinds of triangular flags based on sides and angles. So this is the chart. It just continues. Okay, so each row is a different type of flag they have. So flag 1 has 3 equal sides. That means all the sides of the triangle have the same length and 3 acute angles. Flag 2 has 2 sides that are the same length, 2 acute angles, 1 right angle, and so on. Okay, so it describes each of the 7 flags. Now our problem is right here. The triangle at the right is a model for which flag number? So this flag right here is that flag 1, 2, 3, 4, 5, 6, or 7. So what we're gonna do, I'm gonna redraw it just a little bit larger on the page. Okay, and then I'm gonna take the labels that they gave me. So they said this side was 7 inches. I'm just doing IN for inches like they did. This side was 10 inches. And this side was 10 inches. Okay, so I'm also going to label on the inside of the triangle what each of the angles is. Okay, so that's an acute angle, acute, and acute. So there's 3 acute angles. And then I'm going to label that 3 acute angles. And then how many sides are the same length? So how many equal sides are there? Okay, well that one's 7, that one's 10, and that one's 10. So both of these sides, this bottom side and the top side of the triangle, are the same length. That means they are equal sides. So I'm gonna say 2 equal sides. Okay, so that's all the information I need. I'm gonna look at my chart and see where that is. So first, I guess I'll look at equal sides because that's the first column. So 2 equal sides. Flag 1 has 3, so it can't be that. These all have 2. These have 0 equal sides, so it's not going to be 5, 6, or 7 because I'm looking for 2 equal sides. So it could either be 2, 3, or 4. So those are my options. One of those. But now I'll look at the angles. So I figured out that it has 3 acute angles. That's 2 acute, 1 right, 2 acute, 1 obtuse, 3 acute. Okay, so 2 equal sides and 3 acute angles. Our match is flag 4. So I'm just going to label it. Flag 4. Done. Okay, and this problem, it will go into it, but if I was looking at this triangle types poster, if I look at the sides, so it only had 2 sides that were equal. 2 sides are equal length. So that's this type of triangle, and that word is isosceles. It doesn't look like that. There's just like too many S's and C's and E's in that word. It's isosceles, okay? It's very strange. So it's an isosceles triangle because 2 of the sides are the same length. That's different than an equilateral triangle where all 3 sides are the same length, and a scalene triangle here on the bottom where none of the sides are the same length. Okay, none of them are equal. So it's an isosceles triangle, but it's also an acute triangle because all three of the angles are acute angles. Okay, a right triangle would be one that has one right angle, like that. And an obtuse triangle would have one obtuse angle. So it's an isosceles triangle and it's an acute triangle, which we'll get to. All right, next page. Let's answer some questions about it. So on this page, they're basically just solving what we did. They identified what kind of angles it has. They're all acute angles. See, triangle has 3 acute angles. Yep. And, oh, these are the charts that I just showed you. So this is just the same information as this, but without pictures. So here's the one for sides, like here. Okay, so equilateral, 3 equal sides, like I said. Isosceles has 2 equal sides. Scalene has 0 equal sides. Okay, and then description of angles. Acute triangles have 3 acute angles. Ta-da. Right triangles have 1 right angle. And obtuse triangles have 1 obtuse angle. Okay, so that's all the same information here. I just thought pictures would be helpful, just because these names are all like really long and hard to remember. Equilateral, isosceles, and scalene, like kind of complicated. Equilateral is kind of easier to understand because it's like equal lengths. Okay, so that's how I remember that. Equilateral have 3 equal sides, but these two, it's like those are confusing to remember. And then the angles aren't too hard because it just matches what type of angles they have, right? Acute triangles have all acute. Right triangles have 1 right, and obtuse have 1 obtuse. Okay, putting that aside. So that's that whole page, just explaining. And like we said before, it's an isosceles triangle and an acute triangle. All right, let's answer some questions about our problem on page 735. Gonna zoom in a little bit. There we go. Okay. Now you'll use the problem from the previous page to help you understand how to sort triangles into groups based on kinds of angles and lengths of sides and how to name triangles. So that's basically the whole poster. Okay, if you've memorized that poster, you're in good shape. Okay, number 1, look back at the model for the triangular flag. Fill in the blanks to name this triangle based on its angles and sides. Blank, blank, triangle. So they're not talking about these two, they're talking about the one we had from the previous problem. So that one right there, okay? So we said it was an acute isosceles. See, I had to look at the poster to remember the spelling. Acute isosceles triangle. Okay, now these 2 triangles go for numbers 2 and 3. So look at triangle A above. How many sides are the same length? Okay, well that's 8 inches, 8 inches, and 8 inches, so all 3 sides are the same length. What kind of angles does it have? All of those are acute angles. So I'm going to say 3 acute angles. What are 2 names for this triangle? So if I look at my poster, if it has 3 sides that are the same length, it's an equilateral triangle. But if it also has 3 angles that are all acute, then it's an acute triangle. So it's an equilateral and acute. Equilateral and acute. Okay, number 3. What are 2 names for triangle B? Okay, B is a trickier one. So let's look at this one. 9 inches on this side, 7 inches, and 14 inches. So all 3 sides are different lengths. There are none that are equal. So that would make it a scalene triangle. So that's 1. Scalene. And what's the angle name? So this is an acute angle. That one looks like obtuse, but I'm going to take my Post-it and check. Oh yeah, definitely an obtuse angle and an acute. So if I look at my poster for the angle types, not all three are acute. It doesn't have a right angle, but it does have one obtuse angle, so it's an obtuse triangle. Scalene and obtuse. Okay, can triangle B also be called an acute triangle? Why or why not? Okay, triangle B, remember. Can it be called an acute triangle? Okay, hopefully you're saying no way, because not all three angles are acute angles. It has an obtuse angle. Okay, no, because it has an obtuse angle. Okay. All right, number 4, that's for you to explain. How can you give a complete description of a triangle? So I would say something about figuring out how many sides are equal lengths, figuring out what type of angles they have, matching them to the right type, to the right name, okay? And then for reflect, what models or strategies do you like most about how to sort them, okay? Really, there's not like a lot of strategies. It's kind of just like memorizing the name, looking at the poster, looking at this chart over here on the previous page. So there's not really a lot of strategies, but you could explain what's your favorite way to do it. And then we're going to work on the back page. So we're going to apply what we know, what we just learned about these problems. So pause it if you're not here yet. If you still have to do your reflect and everything, don't skip that part, because when you tear these out to turn them in, I'll know. Go back and do any of the reflect problems if you've been skipping them. And then let's do number 6. Give a complete description of the triangle below. Show your work. Okay, so first I'm gonna label sides. So that's angles. Acute, obtuse, acute. And it doesn't give us the side lengths, but just looking at it, I can tell that this one's short, this one's the longest, and that one's kind of in the middle. Okay, this side is not as long as this side, right? So all 3 sides are different. So no equal sides. 2 acute angles, 1 obtuse angle. Okay, so that's my information I need to know how to classify, how to describe that triangle. So if I look at my poster, if it has no equal sides, that would be a scalene triangle. And if it has an obtuse angle, it's going to be an obtuse triangle. There you go, 1 obtuse, okay? So it's a scalene, obtuse triangle, or obtuse scalene. Usually you put the angle type before the side length type. So obtuse scalene triangle. Star for your notes, star for your answer. Remember, you can always pause it to catch up if I'm going too quickly through the problems. Number 7, what do the triangles below have in common? How are they different? So what's the same about all of them? What's different about all of them? Well, I could look at their angles. That's a right angle. Acute, acute. Right angle, acute, acute. Right angle, acute, acute. Okay, so something they all have in common is that they are all right triangles. If it has 1 right angle, it's a right triangle. So that's the same. All are right triangles. Okay. Now, so that's the angles. What about the sides? This side and this side are the same length. So, same length. This side and this side are the same length. This one, though, doesn't have any sides that look the same length. Okay? So I would say the first triangle and the third triangle are isosceles, because two lengths are the same size. But the middle triangle is scalene, because no sides are the same. Okay, so the first and third triangles are isosceles. But the second triangle is scalene. Okay, that's because these two are isosceles because they have two sides that are the same length. This one and this one, this one and this one. So that makes those two isosceles. But the middle one is scalene because none of the sides are the same length. Okay. All right, last problem on this page is number 8. Which figure is an acute isosceles triangle? Acute isosceles. So an acute triangle means that all three angles have to be acute. So if I label these acute, acute, obtuse, well, A is already out because there's an obtuse angle. Acute, acute, right. That's already out because there's a right angle. I need 3 acute. Okay, acute, obtuse, acute. D's out. That leaves me with only B. Acute, acute, acute. Okay, but is it an isosceles triangle? Isosceles means 2 equal sides. This one is the same length as that one. Okay, if you were to measure it, I don't know why they're not giving us the side lengths. Like, they should just make up, you know, a measurement and say, like, that's 10 inches, and this is 10 inches, and that's 7 inches or something. But those look to be the same length, or you could grab a ruler or something and measure them, but the angles help us there because it has to be an acute triangle, so that's the only one with acute angles. A, and I forgot your star for 7. Okay, done with that part. Now we just have the practice page. Okay, on the example, they had 2 different triangles and they needed to sort them and determine what types of triangles they are. So, good for them. Number 1, look at the table. Name each triangle below based on the kinds of angles it has and the lengths of its sides. So, this is our poster just without the pictures again. Okay, so it's nice that they're providing us with that information. We don't need to grab our little reference cheat sheet or memorize it just yet. So, first triangle, I'm gonna label angles. Right angle, acute, acute. So, let's see, if it has a right angle, then it must be a right triangle. Okay, but that's just part of it. That's just half the name. They should have made these lines much larger. Let me resituate. Okay, so write these words very tiny. Okay, take up like half the line because I still need to figure out the sides part of it. Let's see, 5 meters, 12 meters, 13 meters. So none of those are equal. Then that must be a scalene. So right, scalene. Okay. For the second triangle, acute, acute, acute. So all 3 are acute. That means it's an acute triangle. Acute. And each one is 14 meters, so all 3 sides are the same. So equilateral is the other part of that name. acute, equilateral. Could not fit it on the line. And last one. I know that's acute, I know that's acute. I gotta test that last one. That's an acute angle. Right? That's a tricky one. I think it's an acute. Okay, I need like 3 hands. One to hold my book, one to place my Post-it, one to draw a line. If I draw my line along the Post-it, yeah, see, that's an acute angle because my right angle would be right there and it's narrower, so that is an acute, I was right. What's funny is that I have on my computer screen the teacher manual with the answers right there, and it's telling me that that's an obtuse angle. They're liars. They called this an obtuse triangle. They're wrong. These are all acute, so that's an acute something, okay? They think it's an obtuse triangle on my manual up there, but that's an acute angle. Acute, acute, acute means 3 acute right angles, or 3 acute angles, acute triangle. Sides, so that's 20 meters long. This is 15 and 15, so 2 equal sides, isosceles. Okay, I'll give you a star for each triangle type. I always like when I can find the mistakes in the teacher's manual. That's always fun. All right, next page. And if you did think that was a right angle, because it does look very much like a right angle, that's okay. I understand it's not labeled for you, but you could do something easy like I did and grab your Post-it note and check it, okay? But definitely not an obtuse angle. Silly teacher's manual. All right, back page, and we're done. Okay, I'm on page 738. Number 2. Look at the name of each triangle below. Then use the numbers in the boxes to write the missing length for one side of each triangle. Oh, that's kind of tricky. Okay, so I'm going to separate these because they're all kind of jumbled in there. Okay, so here's a triangle. We have a side missing. We need to decide which one of these measurements goes in the missing box. So if this is an equilateral triangle, and these 2 sides are 11 centimeters, equilateral triangles have 3 equal sides. So if that's 11 and that's 11, then this one has to be 11 centimeters. Okay? I don't know if you can only use it once. I guess it didn't say. We'll find out. The green triangle is isosceles. Isosceles triangles have 2 sides that are equal. Okay, so this one's 10 over here. That means this one is going to be the equal one. Okay, because if you, yep, that's about the same. But it's not going to be 9 right there because look at that length. It's definitely not the same as that. So 10 centimeters is my matching length. This side's the same as that side. Star for that one, star for that one, and your purple triangle. So scalene triangles, scalene have no equal sides. They're all different lengths. So if that one's 11 centimeters, that one's 10. That one has to be something other than 9, or something other than 10 or 11. So it's got to be 9 centimeters. Okay, number 3. Interesting. Write labels inside each triangle formed by the lines in the drawing below. A for acute, R for right, O for obtuse, E for equilateral, I for isosceles, S for scalene. Okay, so that's good. They just don't want us to write like right equilateral in each, like, because some of these are small. It'd be hard to fit the full name of each triangle in them all. So we just have a little code right here. A for acute, R for right, O for obtuse, E for equilateral, I for isosceles, S for scalene. Okay, so I'll just start with this one right here, I guess. Right here on that triangle is a right angle. That's an acute angle, that's an acute angle. So I know it's going to be a right triangle at least because it has a right angle. And it looks to me like all 3 sides are different lengths. So I'm going to say it's a right scalene triangle. Okay. We'll do this big one on top of it. This down here, I guess I might need to measure that one again. That's an obtuse angle. It's close, but that's an obtuse down there. So it's an obtuse triangle if it has one obtuse angle. And all three sides look to be different lengths again, so scalene, obtuse scalene. Okay, we'll do the whole top row first because it's kind of cut in half. So this one right here, all three are acute angles. So it's an acute, and all three look to be the same length, so equilateral. Acute equilateral. This is a right angle, so it's a right, and all three sides look to be different lengths, so right scalene. So right scalene, obtuse scalene, acute equilateral, right scalene. Okay, and then we'll do the same thing down here. This triangle is basically the exact same thing as this one, it's just like longer. So here's a right angle, means it's a right triangle. All three sides are different, so it's scalene. This one next to it, this long skinny one, has a big obtuse angle right up here, so that's an obtuse triangle. And all three sides are very different lengths, so it's a scalene. And last one, here's a right angle, so it's a right triangle. And it's kind of hard to tell. I think those are different lengths, if you kind of look at it at a different angle. So all three are different lengths, scalene. So all of them are scalene triangles except for this one. Okay, kind of looks like a fun art project. All right, and last problem. Which statements below are true? Okay, so because it says statements, it means more than one. So there are lots of possible answers for this one. Okay, A, an obtuse triangle does not have acute angles. Well, here's my obtuse triangle. It has an obtuse, but these other two would be acute, so that's not true. A scalene triangle can be isosceles. Well, those are in the same category. Scalene and isosceles. So isosceles means that two sides are the same length. Scalene means no sides are the same length. So it can't be both, right? Two sides are equal, no sides are equal. That contradicts each other, so not true. Equilateral triangles are always acute. Okay, so here's my equilateral triangle. Acute angle, acute angle, acute angle. So any way you draw a triangle, an equilateral triangle, to have three sides that are equal, all the angles are gonna be acute. You can try another way, but it's not gonna work. They're always gonna be acute. Pretty cool. Isosceles triangles can be obtuse. Isosceles triangles can be obtuse triangles. Let's see. So I'm gonna try and do an obtuse angle. So I'll do a really big wide angle. Okay, so that's obtuse. And if I make those the same length, if that's the same as this, and I just connect them here, then two sides are equal and I have an obtuse angle. So yeah, they can be. They don't have to be, but they can be. And last one, right triangles are scalene or isosceles. So right triangles are scalene or isosceles. Well, right triangle, draw one here. Okay, so that one would be an isosceles because this side looks to be the same as that side. Okay, so that checks out, it can be isosceles, but can it be scalene? Let's see if I make those different lengths now, but still have a right angle. But now these two are obviously different lengths and I connect them. It's still a right triangle, but no sides are the same, so then it's scalene. So yeah, they are. Okay, so there should have been 3 correct answers for that one, so 3 stars. Okay, so that is definitely the trickiest part of this lesson, I think, just because of all of these names and remembering all of this. Luckily, you guys don't have to do the SBAC this year, so you don't need to memorize this. You have this information on the poster, and I'm helping you through these lessons, so that's nice. Next video is for session 5. It's the last one of this lesson. See you there.